Alright, so let's go again. So now we have to focus on the area of triangle PAPR over the area of triangle ABC. So area of triangle APR, I've already highlighted APR, and I also highlighted triangle ABC as well. So now looking at this triangle here, we can see that we are still having a similar situation that we previously had. These two triangles are sharing the same angle. So if they are sharing a same angle or they have a common angle, we use the sine rule. So we are going to use the sine rule for this one as well. So how are we going to do this? We're going to say that half times, only focusing on APR, we know that you have to use the area rule relatively to the common angle, which is A. So what are the adjacent sides there? The adjacent sides are AP. It's AP multiplied by AR there, AR multiplied by sine relatively to angle A here. So we say all over. Then we have half here multiplied by, now focusing on triangle ABC. ABC, what is this side adjacent to angle A there? It's AB. It's AB. The other adjacent side there, it's AC. Then we use the sine rule. We use the sine rule relatively to the area rule. So what are we going to have there? We are going to have sine A here. We use sine A there. Then what's going to happen? We know that 1 over 2 divided by 1 over 2 is going to give us a 1. Then sine A divided by sine A is going to give us a 1. Alright, so that's what we are having there. Then now we are left with AP times AR all over AB times AC. Alright, so from this one here, what is AP? AP, let's look at AP. AP is 3y, so it's 3y. Then AR, I used the same variables for these ones. I didn't notice that. So remember that the variables here, they have to be different, guys. So let's actually fix that. So for this one here, let's just use B for B, 3B. Right, so we are going to use 4B and 3B. So for this one, for AR, it's actually 3B. Let's use it as 3B. Then for AB, it's going to be 7y. Then this is going to be 7y. And then say multiplied by. Then for AC, is going to be 7. This is going to be 7, right? So this is 7B. This is going to be 7B, right? So what do we know, or what's going to happen with the variables there? Know that the variables, this is going to divide with this. This is going to divide with this. Then 3 times 3, you are going to get 9. 7 times 7, you are going to get 49. So that's how we calculate the area. So we can see that even on this one here, we had a case of a common angle between the two triangles. So know that if there's a common angle between those two triangles, we are going to use a sine rule to actually calculate the area of each triangle. So now you can also try and rectify the mistake that we did on the previous two videos of these values here. We have to fix this, because for these are ratios, guys. So whenever for a different ratio, we must attach a different variable, right? So we must attach a different variable. So the mistake that I had made here is to just have 3y again and 4y again. Knowing very well that I've already used y, I should have used a different variable instead, right? Just to show that this is a ratio for a different side. Right, so that's what we are having here. So that's how, but then it won't affect our answer that much. But then just to be consistent when we are working with the ratios and proportions. So that's what we have to do. So remember, if two triangles are sharing a same vertex, they are going to have the same height. And then if two triangles are having the same height, the ratio between their areas is going to be the same as the ratio between their bases. Then now, to calculate the area or the ratio of areas between two triangles that are sharing a common angle, we use a sine rule for each and every triangle there. Then we know that relatively to that common angle there. So that's how we work with this type of triangles. Then the last part that we are going to be working on, it is when we have two triangles that are disjoint, right? So you're going to look at that one.